Hello everybody, I am Suman Matthews and today we will be discussing two topics in differential calculus. The first is differentiation of determinants and the second one would be implicit functions. This is a part of grade 12 maths used in the CBSE, ISC and the state boards. As a maths teacher teaching mathematics for the past 24 years, I would like to share my knowledge of differentiation with you. And as I said before, we would be discussing two topics, differentiation of a determinant, and I would also like to give you an important tip as to how you would differentiate between an explicit and an implicit function. How do you differentiate a determinant? Given a determinant ABCD, you differentiate it as AD minus BC. You just go crisscross, AD minus BC. So if you have to differentiate this 2 by 2 determinant where f1, g1, f2, g2 are functions of x, you can either differentiate it column wise, that is you differentiate the first row keeping the second row as it is, plus differentiate the second row keeping the first row as it is, or differentiate the first column with respect to x because you are doing d dx, keeping the second column as it is, plus differentiate the first column and then keep the first column as it is and then differentiate the second column. Coming to problems, question 1. This is a topic in the grade 12 maths ISC CBSE syllabus. If fx equal to x b b a x b a a x, find f dash x. Here we would be differentiating it column wise. So f dash x would be derivative of the first column would be 1 0 0. Keep the second and third column as it is, plus derivative of the second column would be 0 1 0. Keep the first and third column as it is, plus derivative of the third column would be 0 0 1. Keeping the first and second column as it is. Expanding it, this would be 1 into x squared minus ab minus b into 0 minus 0 plus b into 0 minus 0 plus x into x squared plus b into 0 minus a, that is minus ab, plus x into x, that is x squared, minus b into a. So you would get 3x squared minus ab. Question 2. If ax raised to 4 plus bx cubed plus cx squared plus 50x plus d equal to this 3 by 3 determinant x cubed minus 14x squared minus x 3x plus lambda 4x plus 1 3x x minus 4 minus 3 4 0, find lambda. Differentiate both sides with respect to x, so I get 4ax cubed plus 3bx squared plus 2cx plus 50. Here we are differentiating row wise. So the derivative of the first row would be 3x squared minus 28x minus 1 and 3. Keep the second row as it is. Derivative of the second row would be 4, 3, 1. Keep the first and third row as it is. For the third determinant, you keep the first and second row as it is and you differentiate the third row, that would be 0, 0, 0. So this entire third determinant reduces to 0. Now since we want to find lambda, put x equal to 0 in this equation. So we get 50 equal to 0 minus 1 3 1 0 minus 4 minus 3 4 0 plus 0 0 lambda 4 3 1 minus 3 4 0. Expanding it, you get plus 1 into 0 minus 12 plus 3 into 4 plus lambda into 16 minus minus plus 9. So you get lambda is equal to 2. What is an implicit function? When y is a function of x, we say the function is explicit. For example, y equal to 3x cubed plus 2x. But if we consider the function x squared plus y squared plus 2x equal to 0, y is not expressed in terms of x. We just have an equation. So when we have an equation involving two variables, it is called an implicit function. To evaluate the derivative of an implicit function, we differentiate both sides with respect to the required variable. Question 3. This is also a question in the grade 12 maths for ISC, CBSE and state boards. If sin squared y plus cos xy is pi, find dy by dx. Differentiate both sides with respect to x. So we get 2 sin y into derivative of sin y, which is cos y dy by dx. Derivative of cos xy is minus sin xy into d dx of xy. To apply d dx of xy, you use the product rule. So I get x dy by dx plus y equal to 0 because derivative of pi is 0, pi being a constant. 2 sin y cos y is sin 2y. So sin 2y dy by dx minus, open the bracket, so I get x sin xy dy by dx minus y sin xy equal to 0. So taking out dy by dx, I get sin 2y minus x sin y dy by dx equal to y sin xy. So dy by dx is y sin xy by sin 2y minus x sin xy. Question 4. If sec x plus y by x minus y equal to a, prove that dy by dx equal to y by x. So taking sec to the other side, you get x plus y by x minus y equal to sec inverse a. A useful tip, we have taken sec to the other side, so when we differentiate it, we get derivative of this as 0 because sec inverse a is a constant. Now differentiate both sides with respect to x. Here you will apply quotient rule. So denominator is x minus y the whole squared. Numerator would be x minus y into d dx of x plus y, which is 1 plus dy by dx, minus x plus y into d dx of x minus y, which is 1 minus dy by dx equal to 0. Cross multiplying, the term in x minus y the whole squared disappears. And open this bracket, so I get x plus x dy by dx minus y dy by dx minus x dy by dx plus y minus y dy by dx equal to 0. We can see that x cancels with x and minus y dy by dx will cancel with plus y dy by dx. So we would get x dy by dx minus y plus x dy by dx minus y equal to 0. So 2x dy by dx equal to 2y or dy by dx equal to y by x. So I would leave a question for you. Is differentiating a determinant row wise or column wise easier? Which would you prefer? Leave a comment. And if you like this video, hit the subscribe button. For more videos on grade 12 differentiation, you can refer to my playlist.